Hi, I'm Marc, part of the Simple Switcher business unit here at National Semiconductor. Today I'd like to talk to you about the LMZ 2010 current sharing evaluation boards. There's two key features I want to discuss: the current sharing capability and the thermal performance. So let's look at the board. So here is the evaluation board for current sharing. There is a jumper spot for master and a jumper spot for slave. To connect two boards together, just connect one as a slave. Tie the boards together, and now you have a 20 amp solution. If you want even higher currents, you could add more boards. Let's look at the schematic for this. We have a master module and a slave module. The input voltage, ground voltage, and output voltage are all tied together. In addition to that, for the master, the feedback voltage is connected to the output, and for the slave, the feedback voltage is disconnected. The share pins of both devices are going to be connected to share current information, and the sync pins of both devices will be connected to a clock so that they have synchronized switching frequencies. So let's look at the performance. Here we have two boards. The first is configured as the master. The second is configured as the slave. Each board, we're looking at the current provided by each module individually. We have an input voltage of 12 volts and an output voltage of 2.5 volts. And now I'm going to provide a 2 amp to 20 amp load step. So let's look at the results of that on the oscilloscope. Here we can see the current provided by one module. It is going from 1 amp to 10 amps, or roughly half of our 2 amp to 20 amp load step. Now I'm going to turn on the waveform, or turn off this waveform, and we can see the waveform for the other module, and we can see that it is also a 1 amp to 10 amp load step, so they are sharing the currents quite precisely. The output voltage deviation due to this 2 amp to 20 amp load step is shown here, and we can see that its mean value is 134 millivolts, or roughly 5% of our 2.5 volt output. Now that we've seen the current sharing capability, let's look at the thermal performance. So here we have a thermal camera. Again, we have the configuration set up with a master and a slave. These boards have been providing a 20 amp load current for roughly an hour so that the thermal temperatures could settle. Let's look at the results. We can see here that the hot spot on the board is roughly 73 degrees C. This is only a 48 degrees C rise above ambient. So with 125 degrees C maximum junction temperature for the modules, we have a lot of room for higher ambient temperatures. And this is with no additional heat sinking or airflow besides the boards themselves. Here we can see the master on the right and the slave on the left. In summary, the LMZ 2010 current sharing evaluation boards have excellent thermal performance and current sharing capabilities. For more information, go to national.com/switcher, and thank you for watching.